Okay, what about addition and subtraction? When we add or subtract, we merely combine like terms. What are like terms? Like terms are terms that have the same variable to the same powers. Let's look at this first one. Let's look at 2x plus 3x. These are both x terms. The first one has a coefficient of 2 and the second the coefficient of 3. But to combine 2x plus 3x, we merely add the coefficients and get 5x. What about the next one? 2x plus 3y. The first term is an x term. The second is the y term. We cannot add those two together. We can only add x's to other x's. We can only add y's to other y's. So 2x plus 3y is as added as that one gets. What about 2x squared plus 5x? Now granted, both of these terms are x's, but the first one is raised to the second power, while the second one is raised to the first power. So the way they are now, I could not add them. Now if we want to play what if this were to be x squared, then I could say, well, 2x squared plus 5x squared would give us 7x squared. But we must have the same variables to the same exponents. Let's look at the last one. 3x squared y plus 5xy. Both of these terms have both x and y, but the first one is an x squared y. It can only be added to another x squared y, while the second one is an xy. So these two terms may not be combined. Let's look at a few more. What about x plus 6x? If we look at x, that has an understood coefficient of 1. So 1x plus 6x will give me 7x. What about x plus 0.3x? In this case, the coefficient of x is 1. We might want to write it as 1 or 1.0x. That still means 1x. And 1x plus 0.3x is going to give me 1.3x. Okay, what about x minus 0.4x? Once again, that is 1x. If we wish, we could write it as 1.0x. So 1 minus 0.4 will give us 0.6x. So not always will we have whole numbers as coefficients, but we still need to add or subtract the coefficients.